Hello, everyone. Welcome to, I think it's our third workshop now as a part of the StarkNet Hackathon. And I think we've got workshops every day this week, bar Friday. So it's a super, super exciting week to be here. Lovely to see so many people with their cameras on, as always, at Encode. If you can have your cameras on, that would be ideal. Today we welcome by a very special guest, Vishnu from ZKX. He's going to be running a workshop today. And just a little bit of announcements. I'll be dropping links in the chat while we go on. Please make sure you register for the hackathon if you haven't already. Yeah, please make sure that you are up to speed. You're more welcome to book a call with me in my Calendly. I sent probably everyone that signed up an email today just with my Calendly. I would love to chat to you and kind of see what you're building. I think we've got so many workshops, a lot of us are forgetting that we actually have to build something in the hackathon. So please make sure that you're building something. But let me not speak anymore. Vishnu, over to you. Welcome. Thank you so much for being here.
Yeah, thank you so much. Hi, everyone. My name is Vishnu. I am a part of ZKX, and I'm a smart contracts engineer there. So I have a little bit about myself. So I've been in this space maybe close to 2 years now, and I have been working or developing in Cairo for close to an year. So before that, I used to develop in Ethereum as Solidity. So yeah, let me, before actually we are starting, mostly I wanted to, so there is a very small decentralized application in Cairo plus Solidity that I wanted to talk about. And also more than that, I would actually want to tell you all about the experience that we kind of went through while we started with ZKX and deciding in which blockchain we are going to work on, and our whole journey toward the StarkNet ecosystem. So before going into the actual technical things and workshop as such, I would like to mention maybe a slide about ZKX. So in simple words, basically ZKX is a derivatives trading platform, and yeah, definitely it's permissionless and decentralized. And also we are built on top of StarkNet, and we have a decentralized limit order book, and yeah, that's it. And we all are firm believers of trustless, permissionless, and borderless for all the users. And yeah, now going forward. So basically, when we started thinking about ZKX a while back, it was close to a year back. When we were actually thinking about it, we actually had, from the product perspective, we had a lot of ideas. We decided what exactly do we want. We decided what exactly do we need to offer to the users. And we had a lot of thoughts. But still back then, we had not yet decided where exactly we needed to build on. So we all were Solidity developers back then. We all of my colleagues, we were experienced in Solidity. So obviously one of the first choices was definitely Ethereum. And Ethereum is something that has been around till 2015. And everyone is like users. There are so many users and there are so many decentralized applications in Ethereum, and people, more than everything, people trust Ethereum. So the trust factor is something great. And we all were also actually completely fans of Ethereum. See, we wanted to make use of the security of Ethereum, but at the same time, obviously, all of you, I think, must have used Ethereum, and then you would have probably gone through the problems that happens in Ethereum, scalability issues, congestion, transactions not going through, all of these things. So when we were thinking about the product where actually trading is involved, and when there will be high frequency trading, it's kind of difficult to think from the user's perspective, where users will be paying huge gas fees for each trade. Obviously, it is not ideal, and the user experience would be very bad. So Ethereum, even though it is great, even though it is very trusted, decentralized, and has been around for ages and has been battle tested, it was simply not for us, and we were not able to build on Ethereum. So then since we were all anyway fans of Ethereum and we wanted to make use of the security of Ethereum, we were anyway going to one of the layer 2 solutions. So probably all of you might be knowing what exactly a layer 2 solution is. So there are different types of layer 2 that we had considered. We considered side chains, I mean, not exactly, even different types of, even though are there. Mostly the future of Ethereum or layer 2 solutions of Ethereum is kind of on the layer 2 rollups. And we had considered a couple of options, even though we had looked into sidechains, obviously for a trading platform where security is very much of essence. We were not exactly sure about sidechains. Then we thought about rollups, and in rollups itself, we had two different things, optimistic rollup and ZK rollups. Although after carefully considering, we decided to go with ZK rollups because of the native security that the ZK rollups gives. And I'm not going to talk about the blockchain trilemma for now, but anyway, moving forward. So when we decided to go with StarkNet and Cairo, the thing was that all of us were Solidity developers, and we only had experience in developing Solidity code in Ethereum smart contracts. So we were okay with it. We had built some applications before, but when it comes to StarkNet and Cairo, it was completely new to us. So it's been barely a year since we started building on that. And back then, when StarkNet and Cairo was just coming to AlphaNet in November, the documentation of StarkNet and documentation about Cairo was just very limited. And the only documentation, actually speaking, from StarkNet was from the StarkWare team itself. There was a good documentation from them, and there were some workshops going on. So we attended a lot of workshops. We tried to code along, and Cairo didn't look too bad. But still, when we are stuck at some point, when we are actually coding and when we are encountering some errors, the only help that we used to get is basically from this StarkNet documentation, plus their StarkNet Discord community, which is pretty amazing now, and back then also it was still great. So the experience coming from Ethereum to StarkNet, yeah, Ethereum is kind of like very matured now, and it has so many frameworks, and whatever that we want as a developer, it's mostly there, and it has a lot of because of so much developer support. If we find any problems, or if we are encountering some issues, if you are stuck somewhere, there is always someone to help, or some articles to help, or some Stack Overflow questions to help, and a lot of things like that. But in StarkNet, in beginning, it was so difficult, but now the case is completely different. The number of developers who have been to StarkNet is just staggering, and the support that you get is great. And at the same time, previously, whenever we used to get stuck at some point, when we always had to look at the documentation, but now that's not the case. There are actual articles, and there are actual Stack Overflow questions, and there are actually a special section for that itself. So anyway, StarkNet, as you might have, probably you would have attended several workshops, so you would be already knowing this. It's a permissionless decentralized ZK rollup, and it operates over Ethereum, and it also extends security from the Ethereum. And Cairo is the language that we use to write smart contracts in StarkNet. So maybe let's go a little bit deeper into Cairo and see how exactly is to code in Cairo. I think you would have attended some workshops before in which Cairo, you would have seen Cairo code as well. So I wanted to, before going into the actual application as such, I wanted to maybe say some things or some small learning curve or quirks of Cairo, which I find as maybe interesting or challenging maybe. So if you have worked on Cairo, I think all of this must be pretty much familiar to you, because when you work in the very beginning itself, mostly you will come across all of these things. So one of the things is the usage of recursion over iteration. Most of the times in Solidity or even in the standard high-level programming languages, usually we use iteration for most of the things. It's just convenient and easier to use. But in case of Cairo, we are kind of forced to use recursion, which, if you ask me, is kind of challenging. Maybe some people enjoy it, maybe some people will hate it. But now, at least as of right now, it is what it is, and we have to use recursion. And now coming to the data structure, I mean, data type. The only data type that is available in Cairo is right now felt data type. There is nothing else. There is no string. So even if we want to store something about a string, we have to convert string to felt data type and then store, which, okay, it's okay. And then there is no native concept of arrays here. So whatever that we supported in Cairo is basically mappings, which you might be knowing, which is similar to the dictionary in Python. But it's actually not too bad, because we can use mappings. We can use mappings to come up with arrays. We can use two mappings to actually define an arrays, and sometimes debugging smart contracts using which is actually developed in Cairo can be quite challenging. So I remember an occurrence which happened sometime back where the Cairo contract. I mean, we recently had an audit actually in our ZKX protocol, and we have like around 60 Cairo files or something, and we have extensive test suite for it as well. And all the tests were, while you write the test, obviously anyway, all of these things will passing. So if you remember, there was a Cairo update, a Cairo programming language update that happened 2-3 weeks back. It's from 0.9 to 0.10. It was it brought some syntax changes, and it had some breaking changes as well. So one of the things that happened to our smart contracts was that all these in all our tests, except one test, everything else was passing. And it happened just because of this new Cairo version. So we had no idea what exactly was going on. And also the error message was something like unknown error message at some frame point or something. So we have no idea where exactly which file the error is and which line number it is. And we had to go through a lot of files, actually, a lot of Cairo code and the test code as well. And in the end, it turns out that one of the standard implementations of some ERC20 related to, not ERC20, account implementations by OpenZeppelin had changed their function naming scheme from snake case to camel case. And because of that, the function name changed and the function that we are calling changed. So it was a very simple, small error, which actually had just a name change, but there was no way to identify that error, and we were just stuck there for a while. So some very rarely, it was actually kind of like a lot in the beginning, but now it has actually reduced so much. But still, at some point, we get stuck, and can be quite challenging or complicated to figure out where exactly the error is. And one of the other things that I wanted to say is about Boolean expression. It is kind of quite funny because it is in Solidity is available, and in all the obviously in all the high-level programming languages it is available, but in Cairo, at least as of right now, it's just not possible. There is no Boolean expressions. But at the same time, some of the Boolean expressions, like what you can see on the screen, some of the X or Y, not X or X and Y, some things can be, there are workarounds. But at the same time, if we want to achieve something specific, no, we'll have to probably end up writing many nested if conditions or something like that, which will make our code just big. In our smart contract system, there are several places where we are not able to use Boolean expressions, and we are kind of forced to use some if-else conditions. But being said all of these things, StarkNet has actually announced the new Cairo version 1.0, which would be coming in, I think, maybe in 3-4 months or something, which is going to solve almost all the problems that I mentioned here. So the iterations for loop will be introduced, and new data types will be introduced, and Boolean expressions are also being introduced. So and also I think the whole thing is being rewritten in Rust as well, which is probably will help in some other way too. So by the time the Cairo 1.0 would be introduced, I think it would be so much developer friendly, and probably you will not feel any difference even if you are switching from some other programming language to Cairo. Right now, it seems a little bit different from the other programming languages, I would say. Anyway, later in this some of the slides, there are actually codes in Cairo and Solidity, so maybe we can go through them there. And yeah, that being said, by probably basically started with all the negative things, I think, or maybe challenges. But that being said, now coming towards all the positives that I wanted to say about StarkNet and Cairo. The first thing that I wanted to mention is about the community. So like I said in the beginning itself, when it was like pretty new to the, when the alpha testnet, the alpha testnet was being out back in November itself, the community was pretty amazing. Even though the number of developers were less, the whatever questions that we had, it used to get resolved fast. And now actually the community is so much bigger, and there's if for whatever that you need there, you will be getting help, be it documentation, be it tutorials, or be it just asking questions in the Discord channel. There would be answers for sure. And also the great framework support is another thing. So since Ethereum has been around for like ages now, the frameworks and all the toolings surrounding Ethereum is quite great, as you know. Almost everything that you want is available. But at the same time, if you consider StarkNet, it's not even been 1 year since it is out. And the fact that almost all the good frameworks and tools that are available in Ethereum are available in StarkNet is actually pretty amazing. I was actually not at all expecting that. So when we started out, when we were actually writing our first smart contract back then, the hard hat was just in its infancy. And there was another framework called OpenZeppelin Nile. So we were actually using OpenZeppelin's Nile, and hard hat was not exactly an option because it was just under kind of it's being developed. So we are not able to use that. But now there is Protostar, there is Nile, there is hard hat. And from the browser's perspective, there is Argent, there is Bravos. And even from testing perspective, there are too many. Now it is kind of difficult to keep track of the things that are available. And oops, I accidentally put this in this part, which is from the last slide. Sorry about that. But anyway, and coming to again the workshops and hackathon, as you can see, there are actually so many workshops and hackathon. There are so many workshops and hackathons are happening, and that even our ZKX right now we are having some grants for the from the hackathon perspective, and it's like almost every day, if you decide to start working on Cairo or start to learn StarkNet, maybe there would be a workshop or a hackathon which would be available pretty in the next week or something. And as I said, Cairo just keeps getting better. The Cairo 1.0 version, which I was mentioning again, it just keeps better and better. And yeah, transactions are cheap is something which needs to be mentioned again and again. So if I talk about the transaction cost of Ethereum, I mean, you all must be knowing the transaction costs that are happening in Ethereum, which would be, sometimes it will be $20, maybe $30, it can go up to maybe $100. At the same time, at least in the testnet right now, in the StarkNet, the transaction cost that we see is just very, very cheap. Sometimes I see costs of $0.01, sometimes I maybe 0.1. I think 0.1 or $0.2 is the maximum transaction cost that I have seen in StarkNet. So if you ask about from the user's perspective, it is so cheap. It's like 50 to 100 times cheaper sometimes, like what DYDX is doing. So most of the times, because of this reason, if the platform actually can incentivize the users for using their services, which means that the platforms, because of this less fee, platforms have the ability to incentivize, which means that maybe the users should get to do the transactions for even free. And okay, now I wanted to show one very basic decentralized application using Cairo, I mean, StarkNet and Ethereum. So for most of the applications, I think that I have seen, or at least from the StarkWare perspective, the StarkWare's workshop used to have the code mostly in Cairo. So it felt like it is kind of the Cairo code and the Cairo contract and StarkNet is kind of getting developed in the tutorials. I mean, it's developed in an isolated manner. But we all know that the layer 2 solution becomes actually amazing when it is able to communicate to its layer 1, this corresponding layer 1 effectively. In this case, Ethereum. So the one amazing thing about StarkNet is that the way in which we can build a bridge, the communication between L1 to L2, L1 to L2, and L2 to L1, it's kind of very much free for it's very open for interpretation actually. So we can build it very well. We can build the way we want actually. So there is so much freedom for the developers in the way we build. So the application that I am going to show here is kind of like a small bridge between L1 to L2 using a staking application where a user can deposit some ETH in the L1 contract, and the same information will be communicated to L2 contract, which is in Cairo, and the same thing back. The user will be able to withdraw the funds from L2, which will send a message from L2, which is in Cairo contract, to this Ethereum contract. So this is the withdraw flow, and the previous one, this is actually the deposit flow, where the user deposit and message is sent through StarkNet core contract to the StarkNet L2 contract, which we deploy. And this is the withdraw contract. So for withdraw contract, the user will be directly talking to this contract that is deployed in StarkNet. Sorry. 1 second. Sorry. Yeah. So essentially, for this simple application, we basically have two contracts. One is stake L1 contract, which is deployed in Ethereum, and there is one more contract that would be in L2. So in L1 contract, we like the functionality suggests there is one stake or deposit using which a user will be able to deposit ETH, and there will be a withdraw function which will withdraw the Ethereum to the user's wallet. And then there is L2 contract, in which there are a little bit more functions, but the main functions are this deposit function and the withdraw function. And this is a view function using which we will be able to see the user's balance. And then there is a take fee function, which is to kind of demonstrate how we can manipulate the fees. Sorry, not manipulate the fees, like deduct some amount from the user's balance according to the functionality. So before we move on to the actual code part itself, I wanted to take a moment to discuss about the L1 to L2 communication. So I was, as I was saying before, so one of the important properties of a good L2 system is the ability to interact with the L1 system it's built on. But here, in case of it, StarkNet. So StarkNet contract has like a freedom to interact with the L1 side, which is Ethereum side, and it can send and receive messages to or from any L1 contract. So in order to make this happen, the messages are actually going through StarkNet core contract, which is deployed in Ethereum already by StarkWare. So there are some functions which we can make use of that. So from L1 side, which means in Ethereum, there is a function that is available in StarkNet core contract called send message to L2. This can be used by our Ethereum smart contract to send a message from L1 to L2. And as you can see, these are the arguments that would be needed to address, would be the address of StarkNet contract, which is deployed in StarkNet, and then selector. Selector is actually, you can kind of consider it as a function name, but we use a helper function called getSelector to convert the function name to some integer kind of value. And then payload. So payload can be anything. That is actually a good thing, because it is an array. So in this array, this is defined by the developer. So when we develop an application, the bridge, we can define what is the payload that needs to be transferred from L1 to L2. So if it is just a simple user address and balance, like in this application, we just array elements will be just a user's address and the value of the ETH transferred. It can be anything. It can be like maybe 100 elements or so. Whatever that we want to send, we will be able to send. And what happens is that when send message to L2 function is called from L1 contract in Ethereum, it goes to StarkNet core contract, and it goes from StarkNet core contract to the StarkNet contract, which is deployed in the StarkNet. So in the other StarkNet contract, we would be having a function with the decorator L1 handler, which means that that particular function will only be invoked when a message is sent from L1 to L2, that particular function is decorated as L1 handler. We will not be able to invoke that function any other way. In the code, when the code part comes, I'll show you that anyway. And L1 to L2 communication is kind of simpler compared to L2 to L1 because we just initiate that, we just call that function and the message reaches L2, and in L2 it automatically gets executed. But on the other hand, L2 to L1 messaging is not actually exactly straightforward because when we call this function, send message to L1 function, it is already available in Cairo as a helper. So we can just provide, we can just call this function using this following arguments to address and payload size and payload. But here what happens is that even though we call this send message to L1 function, this message will be sent to the StarkNet core contract, and then it just sits there in the StarkNet core contract. It will not be automatically consumed in the L1 side, which is Ethereum. So in order for this message to be consumed, we have to, we as in the user has to go again to the Ethereum contract and invoke a function which has internally this consume message from L2. So what this does is that when we call this function consume message from L2, our Ethereum Solidity contract will talk to the StarkNet core contract to see whether such a message exists. And if the message exists, that message will be consumed. If it is not there, it will just say that invalid message to consume, and it will be just gone. So it is a two-step process for L2 to L1 communication. We initiate a transaction from the L2 StarkNet contract, which will send a message to StarkNet core contract, and then we have to initiate a separate transaction from L1 for consuming this message, so which makes it two-step. And also at the same time, whenever this communication is required, you must be, now you understood that we have to initiate a transaction from L1, which will consume gas fee of the solid bit of the Ethereum, which can be more. Now, contracts and functions, actually coming to the code part. So the flow would be like the user deposits some ETH, and this message would be communicated to L2, which means StarkNet, and the user initiates a withdraw function in the L2, and the message will be sent to L1. So I have prepared the slides in such a way that it follows the slide. So now this is our L1 contract, which is in Solidity. So in our constructor, we need to just take the addresses of StarkNet core contract and also the stake L2 address. Stake L2 address is the address of our own contract that we deployed on L2. So it just takes in both of these addresses in the constructor. And this is our first main function in Solidity, which user uses to deposit the money or stake money as in, sorry, ETH. So here we take in the, we accept Ethereum, Ether, and also we find out the message sender's address, and we want to send across this information, which is user's address and the amount of ETH that is transferred, both of these to L2. So that's why we are creating an array, which we previously mentioned as the payload. So first element of array is the address of the user. The second element of the array is the value of Ether, how much Ether was transferred. So we prepare the payload, and then we use the predefined function in the StarkNet core contract, which is called send message to L2. And we just call that function with the arguments required. This is our stake L2 address, which is the address of L2 contract. And this will be the deposit function selector and our array. So now this whole payload array will be sent to L2 through the StarkNet core contract. Now we can look at the L2 part of the code. So this is Cairo code. And in Cairo, like I said, there is a deposit function. And you can also see that here there is a decorator called L1 handler, which means that this function will only be invoked if a message comes from L1 to L2. And apart from that, we will not be able to invoke this function externally. I mean, in no other way this can be invoked. So since we previously used the stake method from the L1 contract, the message comes here and it will look for the deposit selector, which is this selector, which is this function. And we check whether we got the message from our own L1 contract just for security purposes. And then here we have a mapping. This is a mapping, user balance mapping. So user balance mapping is just a mapping from address to its balance of the address. So we are just updating the user's balance here. So current balance, you can see we are just writing it as the user's L1 address and the current balance plus amount. So say that if the user has transferred 1 ETH, this now would have become 1 ETH. So now in this deposit function, the only thing that happened is it just received a message from the L1 side and it updated the balance. That's it, and nothing else. And this is just a function to show you how exactly maybe one of the StarkNet only functions look like. So fee in our contract is a predefined constant value, and we are just deducting a free fee from the user's balance, nothing more. This is just for like demonstration purposes. And also, by the way, I also need to mention that all the functions and both two contracts that I am demonstrating here is not written with proper security in mind. This is a very simple application with basically very less security. So I just wanted to mention that. Now just exactly as how we deposited the withdraw flow. So like how I was mentioning before, the withdraw needs to be initiated from L2. And what happens is that when we so we can go through the code and see. So first we check whether the balance of the user, and we need to make sure that the balance of the user is greater than or equal to the amount that the user is trying to withdraw. So that's why we have this assert less than here. So amount should be less than the balance. And then we are going to deduct the user's balance, which is here we are just deducting the user's balance and we are updating the mapping. And then we basically create the payload. Just like how we created the payload in L1, we are creating the payload using which the message will be sent to L1. So we have this is a constant actually, which is to 1, 0, so that the message when it reached on in L1 can understand what exactly is the function that is being invoked, or what exactly is the function that the user wants. So, and we also have user's L1 address and the amount, so that once the transaction is complete, the amount of Ether can be transferred to the user's address. And then we just use the predefined function we already know, which is a send message to L1. And what happens then is this message will be sent to StarkNet core contract. So now what we have to keep in mind is that unlike how the message is sent from L1 to L2, it will not be automatically consumed in L1. It will just go and stay in StarkNet core contract, which is deployed in Ethereum. So consider that now this whole thing got executed, and now our message, which is this message, is just sitting in StarkNet core contract. Now, to complete the withdrawal, what needs to be done is there will be a separate function, which in our case, this is the withdraw function in Ethereum Solidity, which has consume message from L2. So when user invokes this withdraw function, the users we take the user's address and we recreate, like we replicate the exact payload which we send. If you remember, if you look at here, it's withdrawal index, user's address, and amount. Here also it's like withdrawal, it is a constant, and user's address and amount. So we recreate the same exact payload and we send that payload from to the StarkNet core contract, trying to consume the message. So this payload will be checked against the messages that came from this stake L2 address, and StarkNet core contract will check whether such a message exists. If such a message exists, then basically this transaction will continue. Otherwise, it will just fail here itself. It will cause assertion error, and then whole thing will get reverted. And once the message is found, what happens is that it goes to it carries forward with the rest of the execution, which means this particular amount that we know now, it will be transferred to the user, and thus the transfer is completed. So the thing that is, again, just mentioning it again, the user will have to make a transaction in Ethereum. So here the fee of Ethereum would be coming into picture. Now, it was a very small application, which is just involved depositing and withdrawal. And I also wanted to show how exactly the compilation and deploying and everything looks like. So as I was mentioning before, we are actually using OpenZeppelin's Nile framework for maintaining our smart contracts, but we can basically use StarkNet commands also, just like how StarkNet deploys there, we can use StarkNet compile. I just wanted to show one of the frameworks. So using this Nile compile, we compile all the contracts, and then we deploy this contract. And as you can see here, this is the deployed contracts address. So it basically looks almost similar to our Ethereum itself. So we get the contract address here. And just like how we have Etherscan in our for Ethereum, we have Voyager as a block explorer in StarkNet. So this is a like a picture of how Voyager looks like. So you can see that this is our contract address, and right now I'm connected to Bravo's wallet, and you can also see all the functions. So this is the write contract. These are the write functions. Similarly, we will be able to see read functions and also the events and messages and transactions that are happening inside this contract. Sorry. So yeah, so this is basically the Voyager. And also now from the L1, so the flow is like, first we deploy L2 contract, then we deploy L1 contracts, because in L1 contract constructor, we need L2's address. So this is basically Ethereum compiling and deploying. We get the stake contract address. And again, the remix part where we are deploying and we are sending we are actually calling the stake function from L1 so that the message will be sent to L2. So actually here, this is our L2, we have provided our L2 contract address, and the user has deposited some amount of ETH. So now that this transaction here, maybe you can see the transaction got completed. Now, ideally, a message should have been sent to L2, which is in StarkNet Core contract. So in our Voyager, previously, like what I was showing, there is a messages tab in which if you look, you can see that now a message hash is there, and you can see the from address and to address, and you can also see the direction, which means a message came from L1 to L2. And if you look at the messages, if you like basically open the message, we can see the payload, the contents of the message. So if you remember, we had user's address. Now it is converted from hex to decimal. And also this is, I think, 0.001 Ether or something like that. So the value, that value as well. So this is the message that we send from Ethereum to StarkNet in the message. So now this message will be consumed by the deposit contract, which, if you remember, is simply updating the user's balance. Now, if we go to the user's balance, and if we check, like I said, in the read contract part, all the view functions will be shown. So this get balance is a view function. And if we give the user's address and we check the balance, you can see now the user of the balance of the user got updated to the value that we received. So similarly, I don't think I have included the part of withdrawal, but just like this, we can also initiate the withdrawal part. So in that case, using this Voyager, if you go to the right contract part, you will be able to see the withdraw function, which you can call from here, and it will initiate a message from L2 to L1. Then we will have to go again to the L1 contract, which is our stake contract in Ethereum, and you will have to initiate a new transaction, which will consume the message from L2, and the ETH will be transferred to the user. And also, at least as of right now, the one thing that you should keep in mind is that in alpha testnet of StarkNet, there is a delay for message sending from L2 to L1. So L1 to L2 message sending and consumption happens in like maybe 1 or 2 minutes or something. But the L2 to L1 will take a while, because now the block has to get accepted on L2, plus the block also has to get accepted on L1. right now in alpha testnet of StarkNet, it takes around 30 minutes. So due to that reason, if we send a transaction from L2 to L1, the time it takes to get accepted in L1 after 30 minutes, then only we will be able to consume the message. So for withdrawal function in this application which is showed right now, it will take around 30 minutes for consume the message. So before that, whenever we call a withdraw function, it will just show that there is no message to consume because the message is not existing in StarkNet core contract yet. So this is as far as the application actually goes, and you can see all the code related to the application that I have mentioned here in this StarkNet workshop website, and also StarkNet documentation and L1 to L2 communication is given here. And actually, yeah, that's it from my part. And if you have any questions, I would take a look at it now.
Fox asked, is security audit public?
Oh yeah, security audit is not, right now it is not public, but I think in around maybe 1 or 2 weeks around it would be public. Yes.
Perfect.
So there would be a blog coming out soon. You can see it in Medium, I guess.
And then the next question is, well, I was answered, but maybe a good for you to answer it is, what's the difference between Proto, Star, and Nile?
Okay, that is actually something which I am not entirely sure about because I have not used Protostar, but I have heard, yeah, this Protostar is in JS and Nile is in Python. That's there. And apart from that, I have heard actually very nice things about Protostar, but actually I can't comment on that much because I have never used Protostar. I have used Nile and I have used Hardhat, but yet to use Protostar.
Okay, perfect. And then how's building UI for StarkNet? These support React, Next.js, any libraries? Sorry, it's a bit of a hyper.
Yeah, so I am not exactly a front-end person, but when in the beginning, at least our application was on Next.js. So, and right now, if I remember correctly, our front-end team is in the process of migrating it from Next.js to React. But I don't know why, but at least I know that it, both React and Next.js is okay for that. It both works. But if you ask me which is best, I don't know.
Okay, perfect. Someone pinged me with a personal message that I think's a general question, but is the delay just for withdrawal functions?
It's not for withdraw function as such. In the application that I mentioned here, it is for withdraw functions because we are sending a message from L2 to L1. So in general, whenever we send a message from StarkNet to Ethereum, there is a delay. And also I need to mention that this delay is just because it is in alpha testnet right now. So sooner or like later at some point of time, I don't know the time frame exactly. At that point, this time delay will be reduced. It will almost become just like a normal transaction, which will take maybe under a minute or something. It's not there yet. I just mentioned because if you are working on alpha testnet, you will face that. So there is no need to worry. It will come after some time, but in the future, it will be fine. It will just become normal.
Perfect. Thank you, Vishnu. And then what security consideration needs to be considered for this dApp?
So that actually speaking, there is nothing new from a StarkNet perspective. So most of the security perspective that need to keep in mind is the one that you will already be doing in the Solidity perspective. So for example, in this case right now, in this application, there is any user can, I think, withdraw any user's money right now, which is obviously not what we want. And for taking fee also, if you can deduct the fee of user multiple times, there has been no limit. So I just wanted to make the code, the number of lines of code as less as possible. So because of that, I basically removed all the validation assertions. So there is nothing special for it. It's just what you follow in the for the Solidity code itself.
Perfect. And then can you show the GitHub links again from the previous slide, please?
Yeah, sure. I will also be oops, I will also be sharing this slide anyway, but yeah.
And then can we use the same code for layer 2 to layer 2 bridge?
Layer 2 to layer 2 bridge, as in like from StarkNet, where exactly will you bridge it to? I am not sure about that. I don't think so. Because, because it's already.
Is that the correct question, or was there a typo there? Okay, we'll get back to that. What is the advantage of using Cairo and ZKX?
Okay, so that is I think we got confused. So ZKX is definitely like our company which we offer trading platform. Cairo is, I think maybe you meant to ask StarkNet and Cairo probably. But anyway, the main thing is that if you look at the advantages, StarkNet is definitely the throughput increases like considerably. So it is highly scalable, and also the transaction cost. So the cheap transactions is always great for the user, and anyway great for the application developer also, because more users will be coming. And if you want to know how exactly the StarkWare achieves that, mostly the thing is that because of validity proofs, unlike the normal blockchain where we are actually re-executing every transactions, here in StarkWare, in StarkNet, what happens is that there is a prover which generates a proof with the input and output and that function and the program, and all the other node just verifies this function. So all the other nodes do not have to run the same program again, which takes longer time, and verifying takes very less time. So because of that reason, the verification happens very fast, and because of that also it is very fast. Plus, so many transactions are bundled together in one proof, so that when the one particular proof is getting proved, you are actually internally verifying many of the transactions, which again makes it more scalable and makes the transaction cost also kind of gets distributed between all of these transactions and from different users, which actually means that the number of transactions increases, it will get cheaper for you. Unlike Ethereum, where number of transactions increases and the congestion happens. So yeah, I think that's it.
Perfect. So going back to Don's question about the bridge from layer 2 to layer 2, he meant from StarkNet to other rollups. Like
other rollups. Oh, I'm actually not aware of any way in which we will be able to communicate. I don't think it is possible, at least right now.
Okay.
I mean, using this method definitely will not be able to do, because for this we are just basically there is a StarkNet core contract that is sitting on Ethereum, and the communication happens through that StarkNet core contract. And because of that reason, I mean, just because of that, the communication is possible. So yeah, like I said, I don't think right now it is possible for StarkNet to talk to other rollups.
Perfect. And why might I as a staker want to use the example you went through? Is it that I might get better staking rewards on layer 2 StarkNet contracts because of the cheaper fees?
Yeah, so why you might use okay, so definitely one thing is a cheaper cost. So if you think about it, if there is a application that is deployed in Ethereum, and there is an application that is deployed in the StarkNet, since because of the transactions are cheaper in StarkNet, so much more than the Ethereum part, as I was saying before, the application in the StarkNet would be able to even incentivize your transactions. Plus, even all this, whatever rewards that would be getting distributed between users and all of these things, most probably we would be able to distribute it efficiently in StarkNet because of its cheaper fees. So, I mean, this is just a scenario which can happen. I'm not saying that it is for this particular scenario, but yeah, because of whenever the transactions get cheaper, and also when the scalability increases, it's in the end, it's definitely gonna benefit the user only. But if you just create this particular application that I show here, this is just an example application. So there's nothing here much here.
Perfect. Thanks. There's quite a few, Vishnu. Sorry. Why StarkNet as optimism supports rollups as well? Is it due to the Stark versus Snark?
So is it due to Stark versus Snark? Actually speaking, StarkNet and Optimism, even though they are both rollups, it is not Stark versus Snark actually. StarkNet is based on Stark, but Optimism is actually based on optimistic rollup, which is a completely different thing. It is not at all related to ZK proofs at all, actually speaking. Optimism is actually based on, like I said, it is optimistic rollup, which means that in optimistic rollup, all transactions by default are considered to be valid. Like there has been, it is just accepted on L1 directly. And what happens is that there is always a time period in which anyone can challenge the transaction. And if their transaction is challenged, and if it turns out to be not correct, then the person who or the node who verified that transaction would be slashed. That is how the optimistic rollup works. But in ZK rollups and validity proof of StarkNet, what happens is that by default, this proof is generated, and this proof is verified on chain the first time itself, which means two things. One is by default, the security will be more in StarkNet. Plus, other thing is that in Optimism, since it is optimistic rollup, since there is always a time period in which a transaction can be challenged, it takes sometimes operations like withdrawal, it can take up to even days because it can anyway be challenged. So if I understand correctly, some of the applications that are built on Optimism for withdrawal, it takes days, but that is not the case for StarkNet.
And the last question, I'm sure there might be one or two that filter in, is no arrays are available means that it is not possible to use struct type Cairo. Does that make sense?
Yeah, I got it. So it's not exactly. Actually, there is struct. That struct is actually possible. I just meant that just like in Solidity, how we have array of elements, we can just simply form an array of elements. Here, if we want to have an array of elements, it's not possible. We will have to implement an array using mappings. So mapping. So let's say one way in which you can do that is, for example, mapping has like a 0 index, then first element, first index, the element, then second index, the element. We can maintain a mapping like this and a second mapping with the length of the array. So with both of these two mapping combined, you can implement an array. But as of your question, is it not possible to have struct? Struct is also available.
Thanks, Vishnu. That seems to be all the questions. Normally, as I say this, another question pops in. But there's been great feedback in the chat throughout your whole presentation. So thank you so much. I think that was great. I think everyone really appreciated it, and attendance stayed sky high throughout the whole presentation, which is a huge kudos to you. So thank you so much. I absolutely loved it. Everyone absolutely loved it. So thank you so much for being here. And to everyone else, there is an NFT workshop by Aspect DAO tomorrow. Please come to that. That'll be awesome as well. Thanks so much for all of you for being here. And once again, Vishnu, thank you so much. I dropped his Twitter handle earlier in the chat. Give him a follow. I think he deserves it. So thank you so much. And thank you to the ZKX team. All the best, and enjoy the rest of your day. Thanks, everyone.